Okay, this week we're going to start getting into more detail about contact forces and field forces, or into more detail about forces. And the two types of forces are contact forces and field forces. We've already talked about field forces when we talked about gravity. We said gravity does not have to be touching the object to pull on it. It happens at a distance. Any force that occurs at a distance is a field force. So gravity, magnets, um, are the two that you encounter. This is a QR code, and the URL to take you to a YouTube video that shows you something that is important when we're talking about gravity. Remember, we said that gravity always pulls from the center. So for a field force, the center of that object, the center of that object's mass, is what we always have to measure from. Okay, for a soda can, an empty soda can has its center at the red dot. If you put water in the soda can, its center would be at the blue dot. Okay, and you can visualize this. We will work on finding the center of mass for some objects. Some it gets more difficult to find it mathematically, but we can find it a little bit easier experimentally, and that will be part of what our lab is about. So in that YouTube video, you'll see that they balance a soda can on its edge. And I'll show you that in class as part of the introduction for the lab that we're going to do. Here's another demonstration I'll also show in class this week. You can basically balance two forks and a toothpick on the tip of a toothpick. And it seems weird, but as long as you put the tip of the toothpick that's standing vertically right at the center of the two forks and toothpicks mass, when you combine them all together, it will balance perfectly. Okay, so we said the other force is a contact force. There's the field force and there's the contact force. So if it's not gravity or magnets, the whatever is pushing on an object must be touching it. Okay. A contact force acts wherever it is touching the object. And it does matter if it is near the center of mass. Like this little guy here, if he's pushing near the top of this box, he might tip it over. If he's pushing right through the center, where all of the mass is centered, it's more likely to make it move. Okay. In our problems, we will focus on forces that act through the center of an object. That way we don't have to worry about the tilting effect that would happen in reality. Okay, so as far as comparing and contrasting contact forces and field forces, both cause objects to accelerate. A contact force must be touching the object where a field force does not. A field force always acts through the center of the object. The contact force is pushing wherever it is touching. If it is not touching near the center, it is going to cause a tipping effect or a rotation. And we will certainly get into more of that later. I think that is about all on the comparisons. Certainly scan through the textbook pages you're given and check those out. But that should be all for this first recording.